In Activity 10, Asteroids, Meteoroids, and Comets, students are introduced to some of the other satellites that exist in our solar system: asteroids, meteoroids, and comets. You'll need the following materials from the kit. Activity Sheet 10, aluminum pans, 2-ounce paper soufflé cups, 7-ounce plastic cups, steel wool pad, and a pair of tweezers. You'll also need to provide pencils, black marker, safety match, 8.5 by 11-inch sheet of plain paper, pebbles, a pair of rubber gloves, a pair of safety goggles, water, muddy water, and a solar system model from Activity 8. To prepare for Session 1, pull a 2.5 centimeter piece of steel wool from the pad. It's a good idea to wear rubber gloves to protect your fingers from splinters. Spread the piece of steel wool out until it's roughly spherical and about 5 centimeters in diameter, with many air spaces, and then place the wool in an aluminum pan. Make sure to have the safety goggles, safety match, and a pair of tweezers ready for use in the activity. When conducting the demonstration, have a supply of water ready. Wear safety goggles and set up a safe distance from the students and classroom furnishings. To begin Session 1, remind students that planets are satellites of the Sun and ask, do you think the Sun has any other satellites? Accept all ideas. Then, define asteroid for the class as a very small rocky planet that orbits the Sun, and explain that astronomers estimate there are millions of asteroids in our solar system. Inform students that most of these asteroids are no larger than 1.5 kilometers across, but some can be more than 1,000 kilometers in diameter. Point out the area of the classroom model between the orbits of Mars and Jupiter and identify it as a wide band of asteroids. Then, draw 20 or 30 scattered dots of different sizes on the model and label the area the asteroid belt. Next, define meteoroids as miniature asteroids or chunks of rock and metal that orbit the Sun, and ask students, what force might attract a meteoroid toward a planet? Students should recall that the force is called gravity. Then ask, what would happen if a meteoroid's orbit brought it close to a planet? Most students will think that the meteoroid would be pulled toward the planet. Guide students to understand that in this case, the meteoroid might behave in several ways. It might come towards the planet but travel past it. It might go into orbit around the planet, or it might be pulled all the way to a planet's surface. Next, ask students what would happen if the asteroid or meteoroid were pulled to the surface of the planet. Students may be familiar with craters caused by meteoroids crashing both on the Earth and Moon. Explain that when a meteoroid enters the planet's atmosphere, it begins to burn and glow white-hot as it's pulled toward the planet's surface. As it burns up, this meteoroid becomes a meteor. Ask students, who's seen a shooting star? Inform the class that a shooting star is actually a white-hot meteor burning as it enters the Earth's atmosphere. Further describe that sometimes chunks from a meteor may survive the journey through the atmosphere. These pieces of meteor that crash to the Earth are called meteorites, and the impact from meteorites may cause bowl-shaped depressions in the surface of the planet called craters. Ask students, what do you think causes the meteor to burn? Accept all speculations. Next, have students hold a pencil near one end, and with the other hand, rub the shaft of the pencil rapidly back and forth. Ask students what's happening to the temperature of your finger, thumb, and pencil. Students should observe that the temperature of all three is getting warmer. Explain to students that what caused the heat they felt from rubbing the pencil is called friction, or the rubbing together of two surfaces. Next, hold a sheet of paper horizontally and let it fall. Ask students, knowing what you do about the pulling force of gravity, why did the paper not fall straight down? Some students may realize that the air under the paper kept it from falling straight down. Describe to the class that when falling, the paper pushed against molecules of air, which caused friction against the paper. Compare the paper to a meteoroid, telling students that when a fast-moving object, such as a meteoroid, pushes through the particles in the planet's atmosphere, it encounters friction. Ask students, what do you think will happen to a meteoroid as it pushes its way through the atmosphere toward a planet's surface? Encourage responses that mention the terms friction and meteor, and remind the students that the meteor or shooting star looks bright because friction is causing it to burn. Next, retrieve the aluminum pan and show students that unburned piece of steel wool. Hold the wool with tweezers over the aluminum pan. Light the match and bring it in contact with the steel wool. Ask students what is happening. Students should observe that the steel wool is beginning to glow and burn. Explain to the class that just as the steel wool burns and gives off light, so does a meteor burn and give off light in the atmosphere. To conclude Session 1, reinforce this visual and review the sequence of events that causes a meteoroid to become first a meteor and then a meteorite. For Session 2, make a copy of Activity Sheet 10 for each student. Prepare comet head models the day before the activity. Place a few pebbles and some muddy water in a soufflé cup and freeze the mixture. Then transfer the frozen contents of each soufflé cup to the larger plastic cup. Fill the plastic cup with water until almost full and return it to the freezer. Each team of 4 will need a red crayon, a comet head model, and an aluminum pan. To begin Session 2, ask students if they know what a comet is. Many students will be familiar with comets as bright objects that fly through our solar system. Some may even be familiar with specific comets, such as Halley's Comet. Inform the class that a comet is a small rocky mass, usually less than 2 kilometers in diameter, trapped in ice. From Earth, comets look like bright glowing spots with long tails. Ask students, what makes a comet visible to us on Earth? Some students may answer that friction makes the comet visible. Explain that since there is no atmosphere in space, comets do not encounter enough friction to cause it to heat up and burn. Then review the term perihelion with the class and describe to students how when the comet's orbit brings it close to the sun, some of the encasing ice begins to evaporate. When this ice turns to vapor, particles of dust trapped in the ice break free. Radiation from the sun pushes this material away in a tail behind the comet, and these particles reflect sunlight, making the comet visible to us on Earth. Distribute Activity Sheet 10 and give a model comet head in an aluminum pan and a red crayon to each team. Encourage students to observe the model comet head periodically and record any changes to it. Instruct students to complete Activity Sheet 10 by labeling the perihelion and aphelion of the orbit, as well as identifying the head and tail of the comet. Have students also illustrate the change of a comet from a ball shape to a ball with a tail, and remember that this comet tail always points away from the sun, and that the tail is at its longest when the comet is closest to the sun. After teams have completed their activity sheets, ask, what do you think would happen if a comet orbiting the sun passed close to a planet? Students may suggest that the comet would collide with the planet. Guide students to understand that as a comet orbits the sun, it encounters the gravitational pull of a large planet and may begin to orbit the planet that captured it. Finally, to review their understanding, ask students, is there a difference between what makes a comet visible and what makes a meteor visible? Students should respond that a comet is visible because sunlight reflects off a tail made of a vapor and dust particles, whereas a meteor is visible because it encounters friction in the atmosphere, which causes the meteor to burn brightly. To conclude the activity, discard the liquid from the comet heads and dry the aluminum pans. Return all materials, including the pebbles, to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.